So after we finish the Cisco stuff, I want to cover some basic communication components for datacom. So that's going to be things like media, encoding, transmission, modulation, connecting, and multiplexing. Granted, that's not only for datacom, it's also for telecom as well, but I'm focusing more on the datacom portion. This section is going to cover Chapter 5, which again is datacom overview. So it's again essentials, motivations, concepts, and basic subtopics. So Chapter 5 in a nutshell is the overview of datacom, which seems straightforward so far. So what does datacom actually entail? Like, how does datacom work? Like, what is it composed of? So normally datacom composed or involves transmission of data, not information, but of data. Could be of information, but normally just data. Normally, again, over a physical, tangible medium. Now that's not always true though. We could be transmitting data or information over wireless. That's not physical. It does fall under our physical media, but it's not tangible. So do keep that in mind. It's kind of weird that we always talk about our physical medias being wired and wireless, even though wireless is not a physical medium. Just one of those odd things. And of those physical medias, they can be transported over current, electricity, light, fiber, and any other form of electromagnetic radiation. The information is digitized, so basically it makes it into a digital format so that it can be sent over our wire. Again, the wire, I'm just going to subjectively say, is both wired and wireless. So why does it have to be digitized? If it's not digitized, it's still going to be analog, and analog transmissions aren't where we're at anymore. We've switched everything to digital just because they're more reliable, they can be transmitted further and faster. So the essence of our data communications, it's the combination of physics, engineering, and mathematics, and where they all collide, that's where we're defining our datacom. So the motivation and scope of the subject. There are three main ideas, and that's going to be our source information. Again, that's going to be source and destination, not just source, but I mean our sourcing information. Where we're going. The transmission speed, or transmission. Not just so much the speed, but what route, what path is it going to take to get there? How is it going to get there? How do we guarantee that it's going to get there? Do we have to guarantee it's going to get there? Those are all portions of transmission. What happens if we're doing it with a shared transmission medium? Can we have multiple sources? Can those multiple sources go to multiple destinations? Can we share it? Does it have to be shared? Can it be isolated? Pros and cons for both? Those are just some of the topics that we will have to eventually discuss. The second major point is, what about natural phenomenons? If we're transmitting over electrical current, that's natural. Can we manipulate that? What happens if we do manipulate that? Are there any things that can further change it? Like outside radiation, outside noise, things that we don't want to interfere with our communication? Sure, definitely. So what are some other underlying issues? Again, types of media that are out there, and the cost of them, the pros and cons of each of them, the properties of them, the physical phenomenon for the transmission of data over them. That goes back to copper versus fiber, because copper is more susceptible to noise, where fiber is not, but fiber is more expensive. So sometimes by understanding the properties and the physical phenomenons, you can figure out which one that you want to do. Other physical symptoms or other physical issues with that particular type of cable, and problems that can arise during transmission. That's a big one. If we're transmitting multiple miles, can copper go that far? Some copper yes, some copper no. In general though, copper doesn't go that far, so that's a problem that you'd have to consider. Sharing. If we only have one infrastructure, if we only have one medium, how do we share it? Can we share it? Do we have to share it? All good questions. That's actually a major point for our multiplexing, because that's one way that we actually do share a medium. We'll cover that more towards the end of this slide, and definitely within the further chapters. So, let's talk about if we have multiple sources, and they each need to go to a different sender. So how do we actually get a system that does that? Well, what ends up happening is we break it up into several different subsections. The gather, prepare, transmit, extract, deliver. Same thing like when you mail a package. If you're on the East Coast and you want to mail packages to the West Coast, you gather all the packages going to the West Coast. You prepare them. You actually then ship them. Once you get to the West Coast, even if they're going to all different sections of the West Coast, they all get kind of packaged together, then shipped out. That way you're not having to ship out individual. You're just shipping out one big block. Once it gets there, you extract the different packages to wherever they need to go. Some packages may be going to the south, some may be going to the north, some may be going to central. Just kind of depends. And then you deliver them to their individual locations. Graphical representation of that is you prepare it, you send it over the medium, you extract it, then it gets delivered. Each one gets prepared, transmitted over one medium, gets delivered, and extracted at their specific location. What happens if there's errors? We have to provide some type of error correction, but again, we're going to cover that at a later date. It's a lot more complex than that, but I mean, in essence, that's what we're talking about. Here we go. This is our nice, lovely, complex topic. Information. We encode it. We encrypt it if need be. Then we actually encode it on a channel, and we send it to a multiplexer. It gets modulated, gets sent over the wire, it's demodulated, decoded, de-encrypted, and received by the sender, or received by the destination. I mean, even this is kind of simplistic as well, but the thing here is to recognize if we have information, we have to encode it, maybe encrypt it, and send it out. But we're going to be sending it out with multiple connections. And then there's a system in place that will actually multiply it, or modulate it via multiplexer, so that we can share one wire. A great example is like when you get on the internet. Not all of the bandwidth on your home computer is going to just one location. It's actually being combined and sent over that one wire so that you have multiple connections. Again, this is just a concept framework, so it's not concrete. If we're talking about just processing at the sender end, that's the top portion. Information, encode, encrypt, multiplexer, modulate. and then it gets pushed out. On the other end, on the processing the receiver end, it comes in on the wire, gets demodulated, and then resent to the individual destinations. So that's actually about it for Chapter 5. So other areas we're going to talk about will be in later chapters. It's going to be our analog, our digital, characteristics, phases for our multipliers, our multiplexing, amplitude, frequency, phases, encoding, decoding, compression. But there's a few more items that I do want to make sure that we cover, just so that we have a nice understanding. Encrypt versus decrypt. So encrypt is where you take data and you actually can make it private. You can scramble it so that it has to be decrypted. Basically, it makes it only readable for those that have a key to descrambling it. For channel encoding, decoding, that codes it to a channel, and part of that coding to a channel allows for correction. It normally does correction via parity or checksum. Multiplexing versus demultiplexing. So if we have a shared wire, multiplexing is the ability that we have that will put it on a wire, and we can share that wire. Essentially, we take turns. Modulation versus demodulation. That's how we manipulate the electromagnetic radiation. Physical channels. That's our physical medias. Copper, fiber, wireless. How do we send that data? In what type of mode? Are we sending it via serial? Are we sending it via parallel? That's a good question to answer. What's serial? What's parallel? What's our bandwidth? What's our capacity? What's our noise? Those are all major topics we'll be discussing in later chapters. That's it for Chapter 5. Thank you.